Hello everyone and welcome to this e-learning / tutorial video of our Slabs on Ground program GreenSlab within our software package GreenStruct. Before we get started, if you haven't already found your way to our programs, you can find them at greenstruct.dk. And also, if you haven't already registered, you can do so at greenstruct.dk/register. As you can see here on the screen, right now I find myself on our login page, but here at the bottom you can also press register now if you haven't already registered. Alright, but obviously I have an account, so I will go ahead here and log in on my account here, my little demo tutorial account. When you have logged in, the first thing you will see is this project overview page. Here you can see all your different projects and you can see all your different calculations. And also, before we get started with the actual slab program, I would just like to show you, those of you who haven't been on our page before, how to add a new project and add a new calculation. So from this project overview, you can always see all your calculations and projects, and you are able to edit, copy, and delete calculations, but you can also edit, copy, and delete entire projects. A new feature we've added is also this sync data. So if you have changed your analysis parameters, your material properties, or in your foundation calculations, if you have changed any of the geotechnical parameters, you can actually now sync all the data between these calculations to make sure that they all use the same parameters. Alright, to add a new project, up here in the top right corner, I will simply press Add Project, and then I will give my project a project name. So let's just call this one Tutorial. And then I will give the project a project number. This is optional, so you don't have to do that if you don't want to. And then you simply press Create Project. Now you are redirected to this page or this modal where you will then actually add the actual calculation. By default, the calculation will suggest that it's added to the latest created project, but you can also press the drop down and choose to add the calculation to another project. Alright, let's give the calculation a name. So we will call it Slab on Ground. And then you naturally have to choose what type of calculation you want to add. We have the GreenSlab program, which is this slab on ground calculation that we are we're showcasing today. But we also have this wall footing green strip program, or our column pad or point foundation program GreenPad, or the more general cross-section analysis program GreenSection. I will of course choose the GreenSlab program for today's tutorial. Alright, the last thing before we actually add the calculation is that you can actually add introductions or instructions or whatever you want to call it, which will be part of the documentation when we print that out at the end of the tutorial. Here you can either write any text, let's say hello and welcome to the Slabs on Ground tutorial. And you can also press this image icon, and then you can either write the source or upload or drop an image or upload it from your folders. But you can actually also just press Control Copy on any image that you found on the internet or somewhere else, and then actually just press Control V. So as you can see, I have cheated a little bit and already pressed Control Copy on an image, the thumbnail of this video. And Yeah, as you can see, it's a little bit big now, so I will actually press this image icon once more, and then I can edit the size. So I'll say that I want a width of 450 pixels, and then press save. And then, as you can see, the image has now been reduced. All right, that was the last thing I wanted to do before adding the calculation. So let's go ahead and press plus calculation. Okay, once you press plus calculation, you will be redirected to the actual calculation page. And here we have these different tabs on the top here. And you have to fill in all the information in all of these tabs before the program can make your calculation. As you might notice, there's a little green line under this, under the analysis parameters and the material properties, and this indicates that you filled in sufficient data for the program to make the calculation. So obviously, we need green lines under all the tabs before the program can make the final calculations and show the results and so on. The reason that these two, the analysis parameters and material properties, already have a green line under them is because we have chosen some default options to make the process a little quicker. I myself like to just take it from the left to the right, so from analysis parameters to the reinforcement. One last thing. On the left here, you can see that we have this results button, we have the diagrams, we have sustainability and installation buttons. And the reason we can't press the results button yet is, of course, because the program has not yet made any calculations, because we naturally need to fill in all the information required. So similar to these green lines, when you hover over the results button, it will actually tell you which tabs have not yet been filled out in order to make the calculations. All right, let's get started. In analysis parameters, you can either choose the analysis method from the Eurocode or this TR34, which means Technical Report 34 from the Concrete Society. And this is an industrial standard that's been used for more than 40 years, so it's generally accepted for slabs. So let's actually go ahead and choose that. You can then choose the national annex. At the moment, you can choose default or Denmark. And then when you choose the material partial coefficients, by choosing default, it will use the coefficients depending on the analysis method and the national annex. But you can always go ahead and choose your own by choosing user defined and then override all the different material partial coefficients. But for now, let's just go ahead and choose default. Then you can also decide what to do with the shrinkage cracking calculations. You can choose automatic, in which case the program will determine by itself whether it's relevant or not to show the shrinkage cracking calculations. Or you can choose always, then the program will always show the calculations no matter what. Or never, then the program will neglect the shrinkage cracking calculations. When you choose always or automatic, you will have to decide what is the maximum allowable crack width. And also when you choose to have shrinkage cracking calculations, we also need to use this restraint factor to make these shrinkage cracking calculations. As you might have already noticed, for some of the inputs, we have this little question mark. That's a little help text that when you hover over the question mark, you can see, or we try to describe what it is that you're typing in or what you're choosing. So for example, with this slab restraint factor, when you choose default, it uses a factor of 0.75, which is a fairly conservative value, but it also shows where in the Eurocode you can find more information about this factor if you want to calculate it more specifically or using a different method. But yeah, so let's choose default for that factor as well. All right, moving on to geometry. Here you can choose write in or type the slab thickness. So let's type in 2000 millimeters, so 20 centimeters. And let's pretend we're making a warehouse of 20 meters by 30 meters. When I tap away or press outside this input box, since we now have a fairly large slab, the program will give us a warning saying that there's an increased risk of shrinkage cracking. So one or more of these precautions should be taken, and some of the suggestions are to add construction joints, use curing compound, cover the wet concrete with plastic sheets to prevent plastic shrinkage, use shrinkage reducing admixture SRA, or you can reinforce your way out of the issue. The reinforcement we will get to in the end, but one of the suggestions to use joints can actually be found right here. Does the slab contain joints? So let's put a tick box in that. And now you can actually choose a field length and a field width. So let's type in, and again, the hover text here will have some equations on suggestions as to how big these field lengths and field widths should be to avoid having shrinkage cracking issues. So let's type in, for example, 6,000 millimeters by 6,000 millimeters, so 6 by 6 meters. As you can see, the warning text actually disappeared. So just to emphasize a little bit on this shrinkage cracking calculation, now that we don't have a warning here and we've chosen field lengths and field width of a certain size, from an empirical point of view, we are not expected to have issues with shrinkage cracks. So actually now, under analysis parameters, when we've chosen automatic here, the program will actually not include the shrinkage cracking calculations anymore because it is not expected to be an issue. But if we had remained without any, or if we had unticked this joint button here, or if these field lengths and field widths had still been too large than what we prescribe, then the program would actually still include the shrinkage cracking calculations. All right. When you choose joints, you can actually also choose what kind of joints you want. So saw cut joints is the default option. That's where you cut into the slab with a minimum depth of 1/3 of the slab. You can also choose saw cut joints with continuous reinforcement. So that's a combination where we still have the aggregate interlock, so there's still a little bit of shear or load transfer capacity when we choose saw cuts, but with continuous reinforcement it also takes into account the effect of the reinforcement that we have in the middle or in the bottom, if we are to add that when we get to the reinforcement. We can also decide to use saw cut but install dowels, or we can have a situation that's called formed with dowels. That means that the slabs, the two different parts of the slab, are completely separated either by a mold or by being cast at different times. And lastly, we can choose custom. So here you can actually choose a custom joint system. So we can just call it custom joint. And then you can choose both a relative and or absolute load transfer capacity of this joint system. All right, but I will actually go back to the saw cut joint type. Okay, then we are on to material properties. Here you can choose to use default concrete qualities. You can either, and then you choose the standard concrete qualities from the Eurocode. So let's go ahead and choose a C30 concrete here. But if you were to choose custom, you can actually type in the exact material properties of the specific concrete that you're using. Or for some reason, if the slab was to be taken into to use before the standard 28 days, which means that the concrete would not have reached its full strength yet, you can actually type in what the characteristic compressive strength is at that certain time. So let's just say that I write 8 here. Then actually the remaining parameters will actually be suggested based on the equations from Eurocode. So actually I can just tap, and then I tap again, 16, 1.2, 24, 25.3. So you can actually tap through the remaining material properties. All right, also for the shrinkage cracking calculations, we will need to calculate the shrinkage strain, and that includes deciding on the cement class, where you have the slow curing, the normal curing, or the rapid curing cement. You also need to decide on the humidity, the relative humidity. You can either write the exact humidity, or you can choose from this drop down and choose the environment of the slab. And note that this is the environment when the slab is in use. So it's not, let's say the slab is being cast outdoors, but eventually it will be indoors. Then you have to choose the indoor environment. All right. You also can choose the reference age of the concrete, either 28 days, which is standard, but you can also choose 56 days and 90 days. But if you do so, the new Eurocode states that we may require to use different alpha factors. So actually going all the way back to the analysis parameters under the user-defined material coefficients, we would have to change these alpha factors if we are to use these later reference ages. So by default, 28 days, which is also what I myself would choose almost every time. Lastly, under material properties, the program also automatically calculates the CO2 emission from phase A1 to A3 at the moment. If you choose default, I'm actually going to go back here to default. If you choose default, it will use the global warming potential GWP values depending on EPDs from the database on EPD Denmark, based on this concrete strength class that you've chosen up here. But similar to the custom concrete qualities, you can also write your own GWP value based on a specific EPD, environmental product declaration, and write the link to that specific EPD. All right, then we are on to subbases. Under subbases, you can add as many subbases as you want. And similar to these green lines underneath the tabs, the subbases also need to be filled out completely. Right now it's gray and it has this hourglass over here, but once it's been filled out completely, it will change to green and there will be a tick mark. So that's also important to note, that that the subbase will only have a green line once all your accordions have been filled out completely. So actually, if we do add 2 subbases, it's not sufficient that one of them is green and the other one is not filled out. It will not ignore it. It will actually try to compute, which it can't because it hasn't been filled out. So it's important that all your accordions or all your subbases have been filled out completely. So if you don't want to actually keep this lower subbase, let's say, you would have to press the delete button. This also reminds me that you can actually also copy the subbase. So if you filled out all the information and the next subbase is similar, but there's just a few changes, you can copy it and then adjust those few changes. All right, let's press into the subbase here. So first of all, we'll give it a name. So I want to add a insulation layer here. The first thing, by default, it will have ticked off this button here, is the modulus of subgrade known, in which case you can directly type in this modulus of subgrade, this K value, which is the value that this Slabs and Ground program uses as the stiffness parameter underneath the slab. This value has the units Newton per cubic meter, which means that it's actually pressure per deflection. So it's similar to a spring stiffness. But in most cases, we probably don't know this modulus of subgrade, so we will untick this box. And then here you can choose what type of subbase we have. So I will go ahead and choose insulation. Now you can choose what type of insulation. And we have different predefined ones. So if we chose BEWI, which is a producer of insulation, we could choose one of their insulation types, and you could choose type in the thickness of this insulation. We could also choose Sunderlit, another producer of insulation, and choose one of their insulation types. So let's just go ahead and choose, let's say, S100 here, Sunderlit S100, and keep the thickness of 300 millimeters. Lastly, we could choose custom, and here you then have the option to either type in the long-term compressive strength or the long-term modulus of elasticity. When you choose custom and you type in, let's say, the long-term compressive strength, you also need to type in the thermal conductivity, this lambda value. And that's because our program, when you choose insulation, will also make insulation calculations or U value calculations. So the easy choice is obviously to choose one of these predefined insulation types from one of these insulation producers. All right, and then now you will see that it has a tick mark and this accordion is green, and it will actually also have, show the calculated K value, this modulus of subgrade. We will go ahead and add another layer under this. I will call this one sand, and again, I don't know the modulus of subgrade, and this time I will choose ground. Now it will by default have this one ticked off, ticked on. Is any ground information known? If you know any ground information, you need to choose, well, what type of ground information do you know? And there's different options. There's this California bearing ratio, CBR value. There's the long-term modulus of elasticity, strain modulus, as these EV1 and EV2 values, cohesive strength, the CV value, angle of friction, the phi value, and so on. But if we don't know the exact ground information, you can also untick this question here and then choose from these predefined K values. And they come from TR34, the 3rd edition. And now I called mine sand, so I will actually go ahead here and choose well compacted sand. All right, and now we have tick marks in both accordions, and they're both green. And now actually pressing the diagrams, which is always available, you will now see that the cross section here is starting to take shape with the thickness of the slab, the concrete quality, and the 2 layers of subbases. So these diagrams, you can always click the diagrams to see that the things that you've typed in look the way that you expected. All right, moving on to loads. Here you can choose add custom load, and custom loads are loads that you have defined on a account level. So if you always work with certain trucks or certain lorries or whatever it might be, you can add loads to be used in the future in other calculations. Otherwise, you can also choose add predefined load, in which you can choose all the different loads from Eurocode, including these industrial class 1, 2, 3, and 4. You can choose all these different forklift loads and all these different loads from residential buildings, offices, shops, storage, light and medium traffic and parking areas. I will go ahead here since we're saying that we're making a warehouse. I will choose E1 storage here, and then I'll say add load. And then the program will automatically add the point load with the loads according to Eurocode and a uniform load also according to Eurocode. If we were to make a load from the beginning, I'll just press add load. I'll give it a load name here. I'll just call this one racking system. And here you can choose what type of load you want to add. Is it a concentrated load? Is it a line load or a uniform load? If you choose uniform load, you can either choose the characteristic load. So you write in the characteristic load followed by a load factor, either permanent, which will use 1.2, live load 1.5, dynamic load 1.6, or you can choose a custom load factor. You can also just directly type in the design load. For uniform loads, you can choose different load distributions. So unknown is where the program will add the load in the most critical load configuration, so an area with a load and an area without a load, which will result in the most bending in the slab. If you choose everywhere, the entire slab or this uniform load will be applied to the entire slab. But adding a uniform load on the entire slab will actually not result in any bending of the slab. So when you choose this everywhere function, it will actually just go ahead and investigate what the pressure underneath the slab is to make an informed decision on what kind of subbase you want to add. So everywhere will give you infinite bearing capacity in the concrete slab itself. Otherwise, you can choose defined, where you can choose the actual size, let's say, of the uniform load, or you can choose range, where you can choose the minimum or maximum size of your uniform load. So unknown is what I think is used most often because it's the most critical scenario. Otherwise, you can choose a line load. And again, you can choose either to type in the characteristic or the design line load. With the line load, you can choose the position. So everywhere will add the line load both at the edge of the slab and on the internal part of the slab. Otherwise, you can choose custom and say, I only want to investigate this load on the internal part. Or you can choose specific and say, I know that this line load is placed minimum 2,500 millimeters from the edge, so 2.5 meters from the edge. And then the program will actually calculate the specific load capacity, line load capacity for this position and determine whether that's a edge load or an internal load. So everywhere again is the, or not again, but everywhere is the most conservative choice because it will then add the load both at the very edge and on the internal part of the slab. Last but not least, you can choose a concentrated load. And here you can directly choose if it's a single point load, if it's a dual load from, for example, traffic loads, trucks or cars, or if it's a quadruple load. Now I call this load name racking system, so I will actually choose a quadruple concentrated load type, and I will then say 70 kilonewtons. And note that the 70 kilonewtons in this case is the load of the entire system. So let's say it was a dual load, the 70 kilonewtons would be the axle load. So, and that's also what it's trying to indicate here, where it says 1/4 PD, 1/4 PD, 1/4. So each of the 4 loads is 1/4 of the 70 kilonewtons. So the 70 kilonewtons is the load of the entire system. Now that you've chosen a quadruple load, you also need to type in the load distance. So the distance between the loads in one direction and the distance between the loads in the other direction. You can choose the load shape, either rectangular or circular. I will choose rectangular. So this is the footing of the racking system or of your point load. So I will just say 130 millimeters by 140 millimeters. Similar to the line load, you can choose everywhere. Then this point load type here, this racking system load, will be applied both at the corners and at the edges and internal part, and as well as the joints. But if you choose custom, you can choose specifically where you want the point load to be applied. So let's say I know for a fact, since this is a racking system with 4 legs, it's physically not possible to have this load at the corner part. So I will untick that, but otherwise I want to investigate this load on all other parts of the slab. Last but not least, you can choose specific. So I know that this racking system load is at least 1.5 meters by 3 meters from the the corners of the slab. And then the program will also, similar to the line load, figure out if this load is in fact a corner edge internal load. Okay, actually I want to go back to everywhere just to make a conservative choice and investigate this load on all areas of the slab. Alright, last but not least, reinforcement. Here you can choose to add fiber reinforcement or steel reinforcement. You can also add microfibers, which will reduce plastic shrinkage. Or you can also add multiple types of reinforcement, so hybrid solutions. But let's start with the fiber reinforcement. Here you can choose different types of fiber reinforcement, but you can also choose the performance classes or strength classes of fiber reinforcement according to Eurocode, or you can choose custom, where you can then define its fiber name, fiber type, density, and all the required strength parameters of fiber reinforcement. But in this scenario, or in this example, I will use the Durus Easy Finish from Adfil, and then I will choose a dosage. Alright. Just before I add any steel reinforcement, as you can see, we now have green lines under all the tabs, which means that the program has now been able to calculate the bearing capacities of this slab. And as you can also see now on the left side here, you can actually now show the results. You can still see the diagrams. We have the CO2 calculations, and since we chose insulation under the slab, we also have a calculated U value. Alright, as you might also notice, these buttons are blue, but this one is yellow. That means that it has calculated, but it has also found that one area or more areas of the slab or multiple loads have resulted in a utilization ratio which is higher than 100, meaning we do not have sufficient bearing capacity with this load or with this reinforcement or this slab thickness or concrete quality or whatever it might be. But before going into details about that, just to show you here, we have the shrinkage calculations. We have also some insulation capacity calculations, so it will calculate what the maximum insulation pressure was and if that is larger or smaller than the insulation capacity. So in this case, with the Sundolit S100 insulation, we have a short-term capacity of 100 kilopascal and a long-term capacity of 30. So the program will actually say here that your maximum pressure exceeds the long-term compressive strength. This might be okay if this load had been a short-term load, let's say from a truck load or something similar. It would perhaps be all right that the long-term compressive strength was exceeded. But in this case, since it's a probably permanent load from a racking system, we might want to change the stiffness of the insulation or the type of the insulation to have sufficient what's called pressure capacity. Yeah, all right. In this table here, we will see all the different loads, what type of load they are, what position, and it will tell you what the design load is, what the punching shear load is. Note that the punching shear loads are often or always a little bit smaller than the design loads, and the reason for this is that some of the load is actually directly carried by the subbase, so the punching shear load is reduced slightly. The bearing capacity is the capacity against the design load, so in this case it's a point load capacity on the internal part of the slab. Down here we have the point load capacity at the corner of the slab. We also have the punching capacity, and then the utilization ratio, which is the maximum of the bearing capacity versus the design load, and the punching capacity versus the punching shear load. And then lastly, as shown or as mentioned before, we have the subgrade reaction column. Going back to the things that I mentioned at the very beginning regarding shrinkage cracking calculations, as you see here, we don't actually have any shrinkage cracking calculations. And that was because we, under geometry, had chosen small field lengths and widths, so shrinkage cracking is not expected, and because we chose automatic. But if I had chosen always here, no matter the field length and field width, the program will now include the shrinkage cracking calculations. So showing the results again, the program will now include the shrinkage cracking calculations. So in this case, even though we have field lengths and field widths of only 6 by 6 meters, the program will we will need to add some reinforcement in order to reduce this shrinkage cracking. But in this scenario, I will go back to automatic because these field lengths and field widths of 6 by 6 meters will in fact not result in shrinkage crackings. All right, well, as mentioned before, we now have a load here from the racking system at the corner of the slab, which results in a utilization ratio of 130%. What to do about that? Well, we can either increase the thickness of the slab which would be very bad for the CO2 calculation, because we would then increase the amount of concrete everywhere in the slab, even though it is only even though we only have an issue at the corner. So what we can do now is say we want to add some steel reinforcement. Here you can choose the steel quality, you can choose the steel class, you can choose the cover layer both in the top and at the bottom. In this case, or also in general, you can add steel reinforcement everywhere in the slab. But in our scenario, since we used fiber reinforcement and the load capacity is sufficient everywhere except at the corner, we will actually go down here to local reinforcement and only add reinforcement where it's needed. So let's say I want to add some reinforcement only at the corner and only in the top, and I will add some, let's say 10 millimeters per 150 millimeter mesh in the top. Now, scrolling up here, I will actually see that this results button is now blue because we now have sufficient bearing capacity everywhere in the slab. Actually now, since we added so much steel in the corner, it's actually the edge part of the slab highlighted here with green that has the highest utilization. So the one we had here at the corner now actually only has a utilization ratio of 55%. So we could call that a day and say we're happy with the design, but we have now implemented this optimize slab function. So we can actually optimize the slab in multiple ways. We can remain with the thickness we have now of 200 millimeters and then optimize the reinforcement so that this 10 millimeter per 150 millimeter mesh that I added in the top of the slab in the corners, I can have this optimization algorithm optimize that and find a mesh that a much smaller mesh with much less steel to again optimize on the CO2 account. So I can do that by saying I want to add steel reinforcement in the top, and I want to allow for these different diameters, and I want to allow for these different steel spacings. I can also say that I also want to investigate a solution by adding steel reinforcement at the bottom, and at the bottom I want to just allow all diameters and all spacings, and now press optimize slab. As expected, it will say that the internal and edge part of the slab will not require any steel reinforcement because we had fiber reinforcement, but at the top, and we can sort this by steel area, so it will come with up to 3 solutions, one with steel both in the top and bottom, one with in the top and one with steel in the bottom. In this scenario, it only needed to come with 2 solutions, one with top and bottom and one with top reinforcement, and the one with reinforcement only in the top naturally has or not always, but in this case has a lower steel area, so we will go ahead and choose that, and then you simply say add reinforcement selection. What it does is that it then just adds this solution in your input fields here. And now, under results, we now have the corner part of the slab with a 93% utilization. In the diagrams, you will also now see that we have 2 different cross sections, one on the internal part of the slab, or the general slab, where we only needed fiber reinforcement, but we now also have a corner cross section where it shows the corner reinforcement and the position and the type, and in the plan view here it will also show you where this corner reinforcement is required, including anchor length. So this will actually be information that can be used by the constructors so they know exactly what size of mesh they need to use. Alright, but I think we can do more. So right now with the 200mm slab, the program calculates that we have a 71.9 kilograms CO2 per square meter. But since we don't have any issues on the internal and edge part of the slab, I will actually remove the steel reinforcement here, and I will say optimize slab again. But this time I will actually want a little bit more reinforcement in the corner, but I want to reduce the thickness at the edge, or I want to reduce the thickness because we didn't have a very well utilized slab in terms of the capacity on the internal part of the slab and at the edges. So I will say I want to optimize the slab thickness, but I don't want to do it everywhere because then it will suggest a slab thicker than 200mm because we don't have any steel in the corners and the capacity at the corners was not sufficient. So I will say custom, and then I will untick this corner part, and I will say that the minimum slab thickness should be 100mm, and then I'll press optimize slab. Now it will suggest a slab that has sufficient capacity at the internal and edge part of the slab without any steel reinforcement, and it will actually show you the utilization at these parts. So as you can see, the corner will be way overutilized, but we will fix that with some reinforcement after this. So I will go ahead and choose this solution with a 150mm slab. So as expected, the capacity at the corner is now much bigger than it was before, but at least we've reduced the slab thickness from 200mm to 150mm. So now I will go ahead and say I want to optimize the slab with reinforcement, and I could choose everywhere because it will still have enough capacity and at the edges and at the internal part without adding steel. But just to show you, you can also choose custom and say I want to optimize the corner part of the slab with reinforcement, and I will just keep the same options as I had before, and then I will say optimize, and then the program this time will suggest a little bit more steel, but again we'll sort it by the steel area, and then I'll choose the solution where it requires 10 per 200mm mesh in the top of the slab at the corners, add reinforcement selection, and now it will have added this reinforcement. Going back to the results, we now have a 99% utilization at the corner part of the slab. We have reduced the slab thickness from 200mm to 150mm. It required a little bit more steel, but as you can see here in the sustainability calculations, we reduced it from 71.9 kilograms CO2 per square meter to only 57 kilograms CO2 per square meter. So we are happy with this design, and again you can see the internal cross-section, we can see the corner cross-section and the extent that this corner reinforcement mesh is required. If you had a design from a competitor or you had an original design and you want to be able to showcase how much CO2 you actually saved by using our green slab program and this optimized slab functionality, you can actually go ahead and type in the parameters of the original or the reference slab. So I'll actually say 200mm here. We keep the same concrete strength, and well, actually I will choose a mesh here. Let's say that the reference design was a design with 10mm per 150 in both top and bottom. Then the program will now calculate the CO2 that the CO2 emission of the reference slab and the solution in our calculations, and what the savings are in percentage. It will do that both for the reinforcement and for the concrete, and the total percentage of CO2 saved between the reference slab and the solution that we found. And this can also be part of the documentation when we print that. So if I go up here and I press print, you can actually, by default, it will include all chapters, but you can also choose custom, and then I can decide specifically what chapters I want to include in the documentation. And here at the bottom, you can see that you can choose to include or exclude the CO2 calculations, but also these CO2 savings between this slab from green slab or and the reference slab. You can also choose the report date, last edited, created, or custom. These I'll just go ahead and choose default. You can also choose which detailed calculations you want to show in the documentation. So by choosing worst right now, I'm just going to click away here. By choosing worst, it will show detailed calculations of this load scenario here, the racking system at the corner, so the one highlighted with green. But if I choose worst for each position, I'm just going to click away again and show the results. The program or the documentation will now show the detailed calculations of the loads on with the highest utilization ratio at the different parts of the slab. So the corners part, the edge part, and the internal part of the slab. Or you can choose all, and then the program will make detailed calculations of all the different loads in all the different scenarios. This will result in a very long documentation, so this is not recommended. So usually myself, I would choose worst or worst each position. In a few weeks, we'll also have added the custom, in which case you can tick exactly which scenarios you want to include in your documentation. Alright, for now I will just choose worst, and I'll choose default and last edited, and then I will press print, and then the program will automatically generate a documentation. First, you will be redirected to this preview where you can quickly review your documentation and your calculation to see that everything looks right before you ultimately press print and print it to either hard copy or to PDF and save it somewhere on your in a folder somewhere. It's only when you press print here that you will actually use a print credit. So to get to this preview is completely free. Alright, just to show you the documentation, there will be this front page with the project name and the calculation name, project number, the type of calculation, and by who made it. And in this case, it's my initials, Mail, because I'm on this demo profile. Each page will have a header with the logo, which you can change to be your company logo. It will have a table of content showing all the different chapters. It will have the introduction here, where we wrote this custom introduction. Hello and welcome to the Slabs and Ground tutorial, with this little image that I put in. And then it will go through analysis parameters, geometry, reinforcement, sub-bases. This is something that you can also exclude or include in the documentation. These are some additional reinforcement guidelines. We will have the plan view, the cross-section diagrams, shrinkage calculations, the results table with showing all the utilization ratios of all the loads. But then, as mentioned, it will go into detailed or show detailed calculations of this critical load at the corner from the racking system. It will both calculate the load capacity from this yield line method that we use, and it will also show the punching shear calculations. It will show the insulation capacity, both this pressure capacity, but also this insulation U value capacity, the CO2 calculations, the CO2 savings, and lastly, the bibliography. Going to the top, if you found something that you wanted to change, you can simply press Edit Calculation and you will be redirected back to the input page where you can change whatever it is you want to change. Or say after you printed the documentation, you can press Go to Projects and then you will be redirected back to the project page. So I think that was it for the tutorial of our Slabs and Ground program. Please share with us if you have any comments or feedback. We have a very agile development team, so we're very happy to receive any feedback so we can improve the software to make your everyday life easier. All right, have a nice day. Bye.